Hi there, welcome to the last lesson of Phase 2 in our Information Technology series on the Practical Assessment Task, or PAT. I'm glad you're here already, Thabo. Ready for the last stages?
We've covered every aspect of the PAT.
Oh yes? What about the user interface? Let's have a look. We have covered a lot starting with Phase 1. Remember the research and analysis phase? And then in Phase 2, we started with program specifications. And by the previous lesson, we had done almost everything we need to do in Phase 2. Today we'll learn about the user interface design. We're going to refer to everything we've done so far. We investigated and analyzed the problem the client has. We listed the program events and broke them down into their component steps, showing sequence, selection, and iteration. What did we do then?
We created algorithms for every event and drew up flowcharts for the events. Then we created IPO tables for each event and identified data types.
We used the IPO tables to create class diagrams and simple data flow diagrams.
Next, we identified what data should be stored permanently and whether to store it in a database or text file.
Now we're ready to design all intended screens for our program. The reason we leave the GUI till the end is that it is the interface between the user and your program. Common sense tells you that you must design the program before you design the means of using it. At the end of this lesson, you should be able to illustrate and explain the navigation between screens, indicate the accessibility of different screens to different categories of user, and illustrate and explain the intended screens fully. Thabo, you have to identify all the screens of your program and show how the program will move from one screen to the other. Any idea how you'd identify the screens you need?
I could use the list of events I drew up and the flow of events diagram I drew up, like the register event, the log on event, the C game history event, and so on.
Good thinking. You usually show one screen for each event, but you might decide to put 2 or more events on the same screen, and you might add an extra screen like a welcome screen with the name of the program.
Or maybe combine screens.
Yes. Or you can present screens differently, like for example, not show a button to be clicked to open another screen, but rather show different tabs on a background screen. Remember that your client has to approve your design, and they might ask you to make changes. Let's look at an example of a screen. This screen is a background screen. It shows us how to go to 2 events or other screens, register and login, and an extra screen we added. The event screen we select will keep this screen in the background. The more information screen could be used to give instructions for using the program or to explain how the games work. To navigate or move between screens here, the user just clicks on a tab. To navigate to another screen, like a game screen, the user would have to log in, or he could click a button to close the program and move to a goodbye screen. But let's not get ahead of ourselves. We'll look at how to describe the individual screens later. Let's start with the big picture. A good way to illustrate what screens you will need and how the user will move from one screen to another is to draw up a flowchart. A flowchart clearly indicates the navigation between the different screens or GUIs. You can use diagramming software or a presentation program like MS PowerPoint. The easiest is to create your shapes first and then drag them into place. You may use color too when your shapes are in the right place. Add lines or arrows to indicate the flow of data.
Do we have to use particular shapes?
You could use slight variations from the shapes I show you, but it will be easier for others to understand your diagram if you use the commonly used shapes. In the flowcharts for your GUI screens, you need to show the start and end of the flow, or navigation from screen to screen. For this, we use ovals. The screens are shown as rectangles, and the user's choices or actions for navigation are shown as diamonds. The flow from start to end is shown by means of lines to indicate forward flow, and arrows to show you the program returns to a previous point in the flow. The rectangles simply name the screens. We don't show components on the flowcharts. Each named screen will be illustrated later. We can add numbers or letters to each rectangle to identify the screen described later on. Diamonds are commonly used in flowcharts to show selections or choices. In the case of GUI screens, they indicate that the user has made a selection by performing some action.
Like clicking a button or a tab.
Yes, Thabo.
Do we have to indicate this on the flowchart?
Don't name any components like buttons, tabs, and combo boxes. You'll show each action as an option to select when you illustrate the individual screens. Let's take a look at an example of a flowchart for the first few screens that illustrates the sequence of actions and navigation. In this flowchart, the pink diamond shapes show user actions.
The action is the user selecting a choice, right?
Yes. A splash screen is a screen that shows briefly, just a few seconds, giving the name of the program. It closes automatically without allowing any user actions. The flow line shows that we then move to the start screen. There are 4 choices on the start screen: register, log in, get more information, and close program.
Why don't you show close program here?
It will be offered as an option on 2 of the screens. It's a very common option, and it will just clutter up the diagram, so we write a note instead. There will be a close option to close the program on the login screen, and confirmation will be required because closing a program is a critical event. In other words, an event that has more serious effects. A cancel option will be offered for the register and change password screens. No confirmation will be required because these actions are easily reselected. Let's get back to the flowchart. What happens if the user chooses register?
The register screen opens. The user can register. The username and password and the details like first name and surname are stored in the database.
The program returns to the start screen when the user closes the register screen. When the user chooses more information,
information about the program is displayed on the information screen. Then the program returns to the start screen when the user closes the screen.
If the user chooses log in, the program moves to the login screen. The user will be able to choose to change his password on the login screen, maybe by putting a tick in a checkbox. Then the user provides his username and password, which will be checked. If the password is wrong, the user stays on the logon screen. Look how the arrow shows going back to that point in the flow. If it is correct and change password was selected, the user goes to the change password screen to change the password.
What action did the user take to select player or admin?
He typed in the username and password. The program will check whether he entered the username and password of the administrator or not.
So the program really made the choice for him.
Closing the program is also a critical programming event. The user should be allowed to opt out or cancel his choice. The same applies when a user selects a password or registers, because the player may change his mind and need to opt out of the action. What kind of games are you going to have in your pet?
A multiple choice or a match the columns type of game.
So what would the player screens look like?
Well, the 2 games are totally different. The screens won't look the same, so I'd need a screen for each game.
That's right. Each of these game screens must be indicated with a rectangle. Give the game screen a name that is self-explanatory, like multiple choice screen or match the column screen. What options would you offer to the user?
Different choices. Quite a few, I think, like start a new game or change to a different level or give me a hint. Show the correct answer, see my gaming history, or log off or close the program.
That's right, but some of those choices are game choices, not navigation choices. For example, give me a hint would show the hint on the screen where the player selected it. Let's look at a flowchart for player screens that illustrates the sequence of actions. This program will offer either a multiple choice or a match the columns type of game. Note how the green start and end ovals show what happens before and after these events. On the main screen, the user will be able to choose a game type, see his gaming history, like all games played, and log off or close the program. The user will make many choices on the game screens, but we don't show those because they don't navigate to different screens.
What if the player is shown a message in a dialog component? Isn't that a little screen that shows in the middle of a game screen?
You only have to show the main screens. In fact, your client might decide she wants to show the game history on the game screens. Then you could delete the game history screen from this diagram. When the user closes either of the game screens, the program returns to the main screen. That could be when the user clicks a button named Choose a different game type. On the game history screen, the user can only choose to close the screen after he has read the information, and the program then returns to the main screen. So maybe it would be better to show the history on the game screen. I haven't shown you the screens the administrator will use, but by now you should have an idea. Once you've drawn up flow diagrams of every important screen of your PAT program, you're ready to illustrate and explain the intended screens. You have to explain what the screen will be used for, what type of components will be used, which stored data will be accessed from the screen. In other words, data stored in objects in RAM, the database, and text files. You have to explain which user actions are offered within the screen and for navigating to other screens, and which users have access to the screen. Illustrate the design or layout of each of the screens you have shown on the flowcharts.
Can I just make notes about that under the diagram?
No, Tabo. That's a sure way to forget things. Rather, create a table template with 2 columns under each screen diagram. Descriptions such as what it's used for and what it looks like, for example, its size or color. Components like image, labels, buttons, text boxes, timer, progress bar, etc. Data, that is the stored data to be used. Actions that the user can perform. Access, meaning who can access the screen, and validation. In other words, is it required or not? When you decide on components to use on the screens, it's important to remember that they must store user input and output, give information to help the user perform actions, or offer the choices of action. Some screens may have very few components. Take a look at this example of a design for a splash screen. But remember, you must still describe the function and the layout. What would your splash screen look like, Tabo?
Well, it's the opening screen. It must tell the user the program's name and welcomes the player. I'd have a color picture, maybe a logo, as the background of the whole screen, and use a funky font to show the message over the background.
I like it. Good description of the function and layout. The fact that it's only used to welcome the user tells us there will not be many components on the screen. What would you list under components, Tabo?
An image, that's the logo or picture. A label with the program name.
And how would the screen be closed?
It has to happen automatically, so you'd need a timer to close the screen after the time is up.
Good thinking. If you write all of this down, it would look something like this. In this case, no data will be accessed from the screen. No user actions are available because the screen will automatically close after 3 to 5 seconds. All users will have access to it and no validation is needed. Let's discuss the design diagram for a start screen. Remember, a start screen is the first screen the user can interact with. It lets them start using the program. So what components would you list?
You could use an image. You definitely need labels for the instructions and prompts, and buttons for selecting actions.
Yes. If there is very little information, it could even be statically displayed in an output component on the screen. Let's look at the actions for the start screen diagram. Login opens the login screen for players and administrators. Register opens the register screen for new users. Find more information opens the information screen, which explains what the program is about and what it does. Close the program is optional. If a guest user logs in just to see what the program is about, this would be used after he has viewed the information. What about a register screen? What would the components be?
You'd use text boxes for name and password input and grade input.
If you allow every user to input the grade randomly, you'll get dozens of variations. Grade 10, some would do G10, others 10, and so on. How would you avoid that?
A combo box.
That's it. Let's look at an example of a register screen. Take note of the overlapping screen. This is a message which will be displayed when the user has been registered. When OK is clicked, the program will return to the login screen. There, the new user can either log in or see information about the program. Who would have access to this screen?
Everybody. Even the administrator wants to play games now and again. If he wants to play, he'll have to register.
Would any data be stored? And where would you store it?
For sure. Players' input stored in a database.
Yes, you'd need a players table in the database. A new record will be inserted after the input has been checked.
That's validation, right?
You'd also need a levels table in the database. The grades or levels will be copied from the table into the combo box when the screen opens. Rather, don't type it in as a list for the combo box so that if a new level is added to the table, the program will function without having to recode the combo box. In the table for the register screen diagram, the description will include a reference to the input screen. Components and data will be as we stated. We must also mention the buttons needed. The main actions are cancel and register. Cancel allows the user to opt out, not to register. The program will return to the start screen. Should the user click on register, the program will check the input. If there are problems, a message similar to this welcome message will be displayed. It will inform the user of the problem and tell him how to correct it. For example, he may have forgotten to select a grade. Clicking OK on that message dialog will clear the input component where the error was made and place the cursor in the component to set the focus. If the input is valid, the welcome message is shown, a new username is created, and the new record is inserted into the table. You can draw the diagrams for the screens with any tools, including pen and paper. Unfortunately, Thabo, the client still has to approve the screens. He or she could easily say, no, I don't want that, rather do this. So don't do them using fancy formats. And don't clutter your GUI with unnecessary features. If you only need to use something once in a while, rather create a menu at the top of the screen. Once you have illustrated and explained your intended screens, you have completed phase 2 of your PAT.
Yes, at last!
One last thing though, remember to combine all the documents you have created into one document, the design document. You'll have to hand in your work at this stage. Your teacher will give you feedback and make suggestions on how to improve your PAT. You'll have to change your design document accordingly before you start phase 3, because you need to refer to the design to create the program. In the meantime, here's your task for today. This is the design for a screen for a multiple choice test. Draw up a table to explain the components to be used, the data that must be accessed from the screen, the user actions, and the validation requirements. That brings us to the end of our information technology series. If you followed all the steps we suggested, you should be ready for the final phase of your PAT. We've created 4 computer-based lessons that will take you through the implementation in phase 3. Hope they help you. Happy programming!